Hello dear students, how are you all? I hope you all are fine. In today's class, that is in this video, let us go ahead with one more important chapter of your class 7th maths, that is lines and angles. Okay, let us begin the chapter. What is there? What are the concepts to be learned? Let us go through those and analyze. Coming to here, lines and angles. First we need to understand what is a line. Okay, coming to the line, in the textbook it is mentioned, what they have mentioned is, if you take two end points of any geometrical figure, say for example this is a geometrical figure, these are two end points, say for example this is one of the side, right, of that geometrical figure. If it is having side, this side must have two end points. It is over, finished, it is not continuing anywhere, right? If you extend these two end points on either side endlessly, see here also, on either side endlessly, if you extend it endlessly, then we get a line. Okay, that definition, it is said like this: when we extend the end points of any geometrical figure on either side endlessly, we get a line. This is the definition which is mentioned in the textbook, right? Otherwise we can take it like this also. If there are two points which are coincident, say for example point A, point B, okay, two points are there. If they are coincident like this, means both are coming at one position, and if these two points are extending on either side in opposite direction, then also we get a line, right? We can say like this also, but this is the textbook definition, you can just follow that. That is, when two endpoints of a geometrical figure, when they are extended endlessly on either side, we get a line. A line, how do we denote a line? A line can be denoted by just any one letter, small letter, of otherwise L, line, M. You should not show any here end points, it will not be having there because it is extending endlessly. Both the sides it is moving endlessly. If we want to denote this line, then how to denote? By using two letters we can denote. How? Here you have to consider any 2 points on the line. Okay, let us say this as, instead of M, if you take this as A, this is B, this you can denote it as line AB, right? We can denote a line by using 2 points. Those two reference points you can take at any distance from anywhere to anywhere because it has no any limit. A line means it extends. If you are holding a pen in your hand, if you imagine the line along the length of the pen, that line crosses the earth, universe, anywhere. It has no end at all. For that level it continues on either side, this side also, that side also, right? That is a line. Line means we are just considering it as a straight line here, okay, which is extending on either side endlessly. So that is a line. A line is denoted by a single letter or by two letters by using like that. Any 2 points reference point we can take there in order to show that it is straight line, right? This is about a line. Next, coming to line segment. What is a line segment? Just you imagine here a line is passing. Just you imagine like that. Okay, that line where it is passing through this chalk piece, it is passing. Just you imagine. Okay, this part of the line which is passing through the chalk, if I cut and remove it out, this part of the line has two endpoints or not? So this part of the line from where it is coming here, this part of the line from that biggest line it is coming, okay, middle part, we are cutting and taking it out. So this part of the line which is having two endpoints is called a line segment. Segment means what? It is a piece, okay, cut part of the line, that is only segment. If something is given, if you cut into different pieces, how do we get this these pieces? For each piece we can say a segment. In the same way, biggest straight line, if you are cutting a part and if you are imagining with two end points of that part, then we call it as a line segment. A line segment, it is denoted by like this. Say for example this is X, Y. By two letters we denote a line segment because it has two end points, a line segment. Now if you imagine a line along this, now you see both the sides it is going without stopping anywhere. This part of the line what we are taking, that is only line segment. We can denote it as xy, right? This is line segment. Now let us come to know what is a ray, right? I'm not giving the definitions because they are already present in your notes. In textbook it is there already. In case if you want to get the definition of each point, just listen to my words, just go on writing those points. That will be the notes. In order to save the time, I'm not writing all the definitions on the board. Okay, if you just rewind the video and you note down if you want, just like dictation, no problem. Here coming to line over, line segment over, next coming to a ray. What is a ray? If you take, this is a point, right? If I extend this point, okay, from a fixed position, say for example this is one fixed position, okay, from this fixed position one point I'll take. That point if I extend in one direction, endlessly again, means we do not have any end point for that, it is going continuously without stopping anywhere, then we can call this extended path as a ray, right? So how to define that? When a point is extended from a fixed position in one direction endlessly, then we call it as a ray. Remember, okay? A ray, how to denote a ray then? A ray has initial, means starting point it has already. Say for example, this is O, okay? And one more point, where to denote? If you go on taking that end point, it has no end point at all. So just for our reference, in order to show that this is a ray, we are taking any point on the ray, anywhere you can take. So this is how we are denoting a ray. So how to, this point has to be denoted with some other letter, say for example A. So how to denote this ray? OA we can call. See how to denote ray OA. In case if you take this as like this, endlessly it is going. This is O, this point I'll show it as B. Look at this. This is ray OB, right? This is how we can denote our what array. That is line, line segment, and array. Both we learn. Means all the 3 points we learned, right? Yes. Now we have to come to know that when two lines it may be, okay, two lines. You imagine one line like this and one more line you imagine like this, straight lines. They do not have any ends, right? If you imagine, if both the lines, if they are cutting at one point, they are making angles or not, right? They are making angles, right? So what to say then? When two lines or when two line segments or when two rays, when they cut each other at one point, this is very much important. If they are intersecting at 2 points, then they do not make any angle. Remember, because if 2 points means what? They were here one more line and one more line. If they are intersecting at 2 points, they are coinciding. So they do not make any angle. But here, if you take any one line and one more line, if they are intersecting at one point, okay, we call means they make angles, we can say. Here between them angle is formed, right? Anywhere. Now we need to understand what is an angle. Coming to angle, okay, when a point, when two rays are extending from a common point, they make angle, right? From the same point, if they are moving in different directions, not in the same direction, then they make angle, right? This is angle. Then how to define the angle then? Angle is nothing but it is the distance between two rays starting from the same point. Okay, these rays we are denoting with different letters here. Say for example A, this is B. Let us call this as common point as O. How do we denote this angle? Angle AOB. Where is angle formed? At point O. Remember, okay, middle letter denotes the angle. So we can say this as angle AOB. How to write this? Like this we can write. Otherwise angle AOB we denote it, or angle AOB we can denote it like this. So any form we can use, right? This is the method of writing the angle. This is meaning of angle, the distance between two rays starting from the same point. Okay, two rays moving from the same point, we can say. Now we say these are sides of the angle or arms of the angle, arm of the angle or sides of the angle, we say for this one. Sides, which are they? OA and OB. These are sides. Then O is called what? It is vertex. We call this as vertex. O is called vertex. Vertex means what? The point where both the rays meet in order to make the angle. That common point is called what? Vertex. Remember. This is about angle. Next we need to learn what are the types of angles then. There are different types of angles. Let us take first one. Zero angle will take. Okay. Zero angle. Zero angle means what? Here from the same point two rays are moving like this. They are in the same direction. They do not make any angle with each other. Then this type of angle which is equal to this angle, if it is equal to 0 degree, then we call it as zero angle. Remember, first one. Second, coming to what? Acute angle. What is an acute angle? Acute angle means what? If from this common point, if another ray is making an angle with that, if it is moving in different directions, leaving this one, but it should be here less than 90 degree. This angle what it is making with this ray, it should be less than 90 degree but greater than 0 degree. If it is lying in between anywhere above 0 degree, below 90 degree, we call this as what? Acute angle, right? Then we can say this is acute angle. Okay, so how to denote this angle? If the angle is less than 90 degree, right, greater than 0 degree, then we call this as acute angle. Remember. Next, coming to third one, that is right angle. Right angle. What is right angle? If an angle, if it is exactly, if it measures exactly 90 degree, say for example here this angle, we have to denote each angle with three letters. Remember, X, Y, Z. Okay. Next here, coming to this one, M, N, O. Okay, M, N, O. This angle, if you measure, it should be exactly 90 degree. Yes, this is 90 degree. So how to denote this? If the measurement of the angle is exactly 90 degree, then it is a right angle. Remember, after right angle, what comes? Straight angle. No, not straight angle, obtuse angle. Right? Obtuse angle. Next comes obtuse angle. Because just we are crossing 90 degree. After 90, below 180. So that is obtuse angle means you can show this is obtuse angle. L, M, N. Okay. Otherwise, you can show it just like this also. Means I am taking slightly, okay, more than 90 here. So this is also what? Obtuse angle. Then how to denote this? If the angle is less than 180 degree and greater than 90 degree, then you call it as what? Obtuse angle. We can call it as obtuse angle. Next, coming to straight angle. Straight angle means what? Straight angle, as you know already, if the angle is exactly here X, Y, Z, look at this. This angle is what? 180 degree. If the angle is exactly 180 degree, okay, angle is exactly 180 degree, then we can call it as what? A straight angle. If the angle measures exactly 180 degree, then it is a straight angle. Next, coming to here, reflex angle. I'll write here up. Reflex angle. What is reflex angle? If the angle measures, this is 180 degree, right? This is 0 degree. 0 to 180. If the angle measures more than 180. Okay, it is coming here. From here to here you are considering. If the angle measures more than 180 degree but less than 360 degree, it should be below this, but above 180 degree, less than 360 degree, then we call that type of angle as reflex angle. How to denote this? This angle, it should be less than 360 degree and it should be greater than 180 degree. This is reflex angle. And one more type, that is what? Complete angle. Complete angle is so simple, as you know that already. It is equal to, yes, that is, angle should be exactly equal to 360 degree. Then that is complete angle, right? These are different types of angles, just in order to recall these, because they are required in case if you have forgotten. Okay, this is just about angles. Now let us go ahead about different types of angles now, that is complementary angles and supplementary angles we need to learn. Okay, let us go ahead with this. Now let us come to know about what are complementary angles. Complementary angles means what? Here, complementary angles, if you take any two angles, say for example one angle I'll take like this. This is 30 degree, we'll imagine, and one more angle I'm taking, that is 60 degree, right? We need to denote these with different letters, that is A, B, C, X, Y, Z, right? Now if you add both the angles, what do you get? Angle ABC plus angle XYZ, okay, is equal to ABC means what here? 30 degree, right? And XYZ is what? XYZ is 60 degree or not? Total is what? 30 degree plus 60 degree. What is that? 90 degree, right? When you add two angles, if their sum is equal to 90 degree, then we call these types of angles as complementary angles. So simple. When the sum of two angles is equal to 90 degree, we call them as what? Complementary angles. Here complementary angles, here how can you say? Angle ABC is complementary angle of XYZ, or XYZ is complementary angle of ABC. Remember, means to make this as 90, this is required. To make this as 90, this is required. So they are complement to each other, remember. So that is why they are complementary angles. So this is about complementary angles. If something is asked just like this, write the complementary angle of 20 degree. What do you write? Complementary of angle of 20 degree. Total it has to be 90. What you have to add to 20? 70 or not? Then 70 is complementary angle of 20 degree. This is how we need to find out. Okay. In case if it's not, if you are not able to guess that immediately, you do like this. What complementary angle? You don't know, right? If it is given, say for example, 55 is given. Okay. What is the complementary angle? You don't know. Let us write that as what? One angle. So what we say? That is angle is equal to 90 degree. Now angle, this 90, you take that side. 90 minus 55 you do. What do you get here? Angle A is equal to 90 minus 55. You are getting 35, right? 35 degree. This is what? Complementary angle of 55 degree. If you add 35 and 55, you are getting 90 degree, right? This is how we find out the complementary angles, remember. Next, let us go ahead with supplementary angles. Coming to supplementary angles, if the sum of two angles is equal to 180 degree, then they are called supplementary angles. So simple. Now, say for example, here this is one angle and one more angle will take like this. Okay. Now this is one angle. This is, say for example, this is 130 degree and this is 50 degree. Okay, if you add both the angles, the sum must be equal to 180 degree. Means if you add this angle, this will be equal to 180 degree, right? That is 180. If the sum of any two angles is equal to 180 degree, then such a pair of angles, they are called what? Supplementary angles. Simple one. Okay, if I ask you here 180 degree, okay, 180 degree, not 180, say of 95 degree. Okay, what is the supplementary angle of this given angle there? If it is asked, then what you have to do? What you can add to this one in order to get 180? For that, if you add 5, it becomes 100. Next 80 means 85 you need to add, right? If you add 85 degree, this will be equal to 180 degree. Then we can say 85 degree is the supplementary angle of 95 degree, or 95 degree is the supplementary angle of 85 degree, because their sum has to be 180 degree. Remember, these are pairs of supplementary angles. If you write here, just we will say L, M, N, X, Y, Z. If you add this angle L, M, N plus angle X, Y, Z, right? This sum LMN is how much? 50 degree plus this is 130 degree. Okay, what is the sum? It is equal to 180 degree. Therefore, angle LMN and XYZ, LMN and XYZ are supplementary angles. Supplementary angles. Remember. Okay, this is how we can say that the given angles are supplementary angles. Now, let us go ahead with pairs of lines now, right? Okay, pairs of lines. In this, let us take intersecting lines first. Intersecting lines. Now, remember, here pairs of lines means two lines, that is called pair. If there are two lines, they are pairs of lines, right? If you consider any two lines in that is one pair, right? If you take one pair of line, how we are taking? Intersecting lines. Just to remember, we can draw the lines only in three ways, on the board or on the notebook, wherever it is. Which are they? First one, intersecting lines. How? If you draw here one line and if you draw one more line, these are intersecting lines 100%. Why? Because these are not touching at all there. They are not touching at all. How I am saying that they are intersecting lines? Remember, line means it continues, right? If you extend this line and if you extend this line, they must cut at one point or not, because they do not have any end. So at one point they have to cut, right? So that is why we can call what? These lines as intersecting lines. Okay, at any angle they may be there. If you extend those, they are cutting at one point. Then we can call them as what? Intersecting lines. Intersecting lines, they do not cut at 2 points. Remember, any two lines at one common point, if they are meeting only at one common point, however you extend, no matter. Okay, if they are meeting at one point, then we call it as what? That pair of angle, what are lines? That pair of lines as what? Intersecting lines. Remember. And if you take line segments, they do cut each other. Okay, if they cut, say for example, here if you take any geometrical figure, square, if I take these two lines, if we extend, they are cutting each other. Okay, these line segments, they are meeting at one point, that is common point. So that is why we can say that these are also intersecting line segments, we can say, right? Lines are also intersecting here. Line segments are also intersecting, lines are also intersecting. Okay, remember. Next, rays. If you will take two rays, if they two are meeting at one common point, then these are also intersecting, right? Remember, all these are intersecting lines. Any two lines, if they are meeting at one common point, then we call such a pair of lines as what? Intersecting lines. Remember, okay? This is about intersecting lines. Next, coming to what is transversal here. Then the transversal, if there is a pair of line, okay, I'm taking a pair of line, they are intersecting lines, of course, no problem. This pair of line, if you take here, any line which intersects two lines at two distinct points, okay, at a distinct points it has to meet, not at one common point, then we call it as what? Transversal. Okay, then according to the definition, if you extend this, they are meeting at this one point here, right? Here, if you draw a line here through this is not a transversal, this is just a line, we can say, right? But transversal means what? It has to cut two lines at a distinct points. See, this line, this is L, this is M. Two lines are there, right? These two lines here, if they are meeting transversal at one point, this line L is meeting at one point, this is called, this point, let us take it as A, this point as B. Okay, at two distinct points, a line is cutting the given pair of lines, then we call such a line as transversal. Remember. Now, what is the point where these two lines are meeting each other? This point is called what? Point of intersection. Okay, we call this as point of intersection. It is called point of intersection. Remember. Here these two points are distinct points, it is cutting. That is why this line is called what? Transversal. This is transversal. Remember. Okay. Now coming to here transversal. Now this transversal, when it cuts a given pair of lines, it makes angles. Those angles we need to understand what type of angles are formed there. First we need to learn those angles first. Okay. Now angles made by transversal with a pair of lines. Let us take, these are two lines. This is a transversal. Okay. Now here you can take here. Here angle is formed between these two lines, and here also it is formed, right? Next, in the same way, here also it is formed, here also same, right? And this is one more pair. Here one more pair. At distinct positions, we are finding different angles, right? Now we are giving particular names for those angles now. Now you see how above this line, above the line and to the left, we are taking this one angle here. Okay, this is 1, 2, 3, 4, 5, 6, 7, 8. Now you consider this angle where we are taking above the line to the left of the transversal, right? Here also if you take above the line and to the left of the transversal, we call this pair of angles as corresponding angles. Remember, they are called corresponding angles. Here also to the right of the transversal and above the line, this is, and here also above the line and to the right of the transversal, this angle. Then we call this and this as pair of corresponding angles. Next, if you take here below this line and to the left, this is angle. Here also below the line and to the left, this angle and this angle, again a pair of corresponding angles. Remember. Okay. In the same way here also, just to the right of the transversal and below the line, to the right of the transversal and below the line, 3 and 7, this is also pair of corresponding angles. Okay, just we will write that later with along with numbers. Now we will take inside the line. This is line, this is line. Okay, between the lines what angles are coming inside, they are called interior angles. Okay, these are interior angles. And above the line outside, these are coming 1 and 2, and here 8 and 7 outside the line they are coming, right? These are called what? Exterior angles. These are interior angles. 3 4 5 6 interior, since they are coming inside the lines. 8 and 7 and 1 and 2, these are outside the lines, so they are called exterior angles. Next, coming to here 4 angle 4 and 6, these are in opposite directions but they are inside the lines, right? So we call that type of angles as what? Pair of alternate interior angles. These are pair of alternate interior angles, that is 4 and 6. In the same way, if you find out 3 and 5, okay, they should be in opposite direction and they should be on either side of the transversal. Either side means this side and that side. One is on the right, one is on the left, and this is facing in this direction and this is facing in this direction, right? These types of angles, they are called what? Pair of alternate interior angles. And these are what? These are pair of alternate exterior angles. This is facing this side, this is facing that side. These are pairs of alternate exterior angles. Okay, you need to remember. Now let us find out here which are those corresponding angles and alternate interior, exterior, everything there, right? Okay. Now, if you take here angle 1 5, if you write this as angle 1 and angle 5, 1 and 5, next 2 and 6, okay, angle 2 and 6, okay, angle 2 and 6, next angle 4 and 8, angle 4 and angle 8, 4 and 8, angle 3 and 7, angle 3 and 7. These are called what? Pairs of corresponding angles. These are pairs of corresponding angles. Pairs of corresponding angles. Remember, all these are pairs of corresponding angles. Right? We found out which are the pairs of corresponding angles we wrote here now. Now let us take another set here now. Angle 4, here 3, 4. Angle 3, 4, 5, 6. Angle 3, angle 4, angle 5, angle 6. What are these? These are interior angles. They are just interior angles because since they are coming inside the lines, they are called interior angles. Interior angles, these, right? Next, coming to here 1 2 means it is outside the line. 8 7, these are also outside the line. Since 1 angle 2, next 8 and 7, angle 8 and angle 7, or 7 and 8, both you can take. 1 2 we have taken, 7 and 8 will take. 7 and 8, these are what? These are exterior angles. These are just exterior angles. Now you see, these are interior angles, these are exterior angles, these are pairs of corresponding angles, right? Next, coming to one more type here. What is that? Angle 4 and 6, angle 4 and 6, angle 3 and 5. Okay, so we'll take here angle 4 and 6, angle 6, next angle 3 and 5, angle 3 and 5. These are called what? Pairs of alternate interior angles. Alternate means on opposite sides of the transversal. Okay, and they are inside the lines, so that is why they are pairs of alternate interior angles. Alternate interior angles. right? Pairs of alternate interior angles, remember. And one more set. What is that? Angle 1, angle 1, angle 7, right? Angle 1 and angle 7. Angle 1, angle 7 in opposite directions. Next, angle 2, angle 8. Angle 2 and angle 8. What are these? These are pairs of alternate exterior angles. Over. So only these sets of angles we are going to learn. Once if you learn this, next we are going ahead with pairs of lines which are parallel to each other. Okay, means a pair of lines which are parallel, that we need to study next. Okay, okay. We need to learn what are parallel lines. What are parallel lines? If you take any two lines, how to define that? If you take here one point, any one point, refer this as x, this as y, this is a, this is b, right? Now if you measure the distance between x and y, if it is 10 centimeter, and here also if you measure, this should also be 10 centimeter. Okay, we call these x and y as corresponding points on the two lines. Here a and b are also corresponding points on the two lines. These lines let us denote it as L and this as M, or P and Q you can take if you want. Now how to define parallel lines? If the distance between any two corresponding points on two lines, okay, any two points on that is distance between any two corresponding points on the two lines, if it is same, same is exactly equal, then we call such a pair of lines as parallel lines. Remember, if you want to, you can take down just by dictation what I'm saying here. If the distance between any two corresponding points on the two lines is equal or same, then such a pair of lines is called what? Parallel lines, remember, right? This is about just parallel lines. Examples if you take, so many are there. Here transversal parallel lines, for that I'll give. Okay, those examples we are coming across later. With these pair of lines, if you take here, uh, exactly it has to be same. Frame of the door if you take, they are parallel, right? Like that you can take. Other examples if you take, here your desks, benches, whatever you take, that measurement will be exactly parallel. Even if you take the board, here board is also parallel actually. If you take the hanger, tube light you take, it is exactly having equal width. Okay, so we can say that lines drawn along the edges of that particular shape or figure, that is giving us what? Parallel lines, remember, right? And railway tracks, they never meet each other, right? They are equal in distance anywhere, right? So that is why such pair of lines, they are called what? Parallel lines, remember. Next, coming to here, these angle made by a transversal with pair of parallel lines, that is very much important. Our main concept is coming now, right? Here let us take here one. Now let us imagine this is line P, this is Q. Okay, two lines we are taking. This is a transversal, right? This is a transversal. These two lines we are imagining as parallel. Parallel means with exact measurement we need to draw that, but roughly I have drawn. Just let us imagine they are parallel. If they are parallel, if you measure different angles, we are getting some conclusion we are getting. What is that here? This is line P, this is line Q. Let us denote this transversal as A and B. Okay, this is a transversal. When it cuts these two lines at 2 points, say for example we'll give for this as x and y at two distinct points it is cutting. Okay, it is intersecting, transversal. Now what we can say here, angles are formed here, this angle, this angle, right? We'll write this only here, it will write. Now angle, these two are formed here also. What are these? As we already learned, now these are corresponding angles, right? Here also corresponding angles, these are corresponding angles again, here corresponding angles, right? Now how do you say when if two lines are cut by a transversal, if a pair of parallel lines, if a pair of parallel lines, that is very much important, not any lines. If a pair of parallel lines is cut by a transversal, then the pairs of corresponding angles, the pairs of each or each pair of corresponding angles measure equal. Okay, means if you measure, this is say one angle 1, 2, 3, 4, 5, 6, 7, 8, right? How to prove this? Angle 1, angle 1 is equal to angle 5, angle 5. These are called pairs of corresponding angle. Each pair of corresponding angles, they are equal in measure, they are saying there. Here angle 2 and 6, angle 2 is equal to angle 6. These are also corresponding angles, pairs of corresponding angles. Next, angle 1 and 8, not 1, there is angle 4 and 8, angle 4 and 8, angle 4 is equal to angle 8, corresponding angles. Next, coming to angle 3 is equal to angle 7, angle 3 is equal to angle 7. These are each pair of corresponding angles, they are equal in measure, remember, means all are equal. This is equal to this is equal to this, 4 is equal to 8, 3 is equal to 7. If you measure exactly, they will be equal. What is the condition? The lines have to be parallel, they have to be cut by a transversal, only then this fulfills condition, otherwise it is not holding good. Next, coming to these are what are each pair of corresponding angles. Okay, pairs of corresponding angles, they are equal in measure. This is one corresponding angles. Next, coming to this is 1 over, and coming to the next conclusion here, corresponding angles over here, alternate interior angles will take. Okay, alternate interior angles if you take, each pair of alternate interior angles, they too are equal in measure. Okay, each, then how to define this? When a transversal cuts a pair of parallel lines, then each pair of alternate interior angles are equal in measure, remember. So how to say that? Here angle 4 is equal to angle 6, angle 4 must be equal to angle 6. Next, angle 3 must be equal to angle 5, angle 3 must be equal to angle 5. These are what? These are pairs of alternate interior angles, alternate interior angles, right? Pairs of alternate interior angles. Next, coming to here also same. Here angle 2 will be equal to angle 8. Okay, angle 2 must be equal to angle 8 if you measure. Next, angle 1 must be equal to angle 7, angle 1 must be equal to angle 7. Then these are what? These are pairs of alternate exterior angles, right? This is one more. Next, coming to last conclusion. what is that? The sum of, here, the sum of interior angles on the same side of a transversal is a straight angle. Means what? The sum of angle 4 and 5 must be equal to 180 degree. If you measure 100%, it is exactly 180 degree. Angle 4, angle 4, see, plus angle 5. These are angles on the same side of the transversal, that is on the left side, remember. This sum if you take 4 and 5, this will be equal to 180 degree. Means what? If it is 180 degree, this is called straight angle or not? Straight angle. Straight angle. Right? Next coming to here. And 3 and 6 if you take, angle 3 and angle 6. These are also what? Equal to, if you add these, it will be equal to 180 degree. Right? So what do we say? The angles on the same side of the transversal. The angles on the same side of the transversal, if you add them, it will be equal to 180 degree. They are equal to a straight angle. Sum is equal to straight angle, not each angle. Sum of these two angles on the same side of the transversal. How they have to be there? They have to be interior, not exterior. Remember. So what we can say? The sum of interior angles on the same side of the transversal is equal to 180 degree, or it is a straight angle. Okay, this sum. And here also 3 and 6 if you add, angle 3 and angle 6 if you add, it will be equal to 180 degree. Okay, these are some of the concepts which are given. Just you practice that. Okay, next last one point remains, that is what? Checking the parallelism of a given pair of lines. Means whether the given pair of lines, whether they are parallel or not, we need to check. How do we check it? Very simple. If you measure here transversal, here two lines are there, they are cut by a transversal, right? Then if you prove that each pair of corresponding angles is equal, if each pair of corresponding angles is equal, then you can say these lines are parallel 100%, because in the beginning what we said, if a pair of lines is cut by a transversal, if a pair of lines is cut by a transversal, each pair of corresponding angles are equal. Okay, this is the condition. If each pair of angles are equal, then the lines have to be parallel or not. This is the condition. Okay, what we have told, same thing it is coming. So here, and this pair you can take. Otherwise, you can go for other concepts also. What here? Pair of alternate interior angles you take. If pair of alternate interior angles are equal, then means the pair of interior angles made by transversal, when it cuts a pair of lines, if they are equal in measure, we can say that the lines are parallel, because these cannot be equal unless the two lines are parallel. Remember, this is checking for parallelism of the given pair of lines, right? This is very much important. So till here your entire chapter got over now. Okay, it is finished. Just if you go through that, wherever you want definitions, you pause the video, just you revise, and you take the dictation and note down points, right? This is the what lines and angles, the lesson completes here. Okay, and I'm going to see you in the next video. Let us take one science lesson in the next video. As much as possible, you try to share the video with your friends, because you should not leave anybody to lag behind, because you have to help others. If you are helping others, you will be at higher level again. Okay, your knowledge still increases. That is the rule of nature. That is from the universe, it is coming like that. Just you share with your friends, and you make them good, you will become excellent, right? This is a suggestion what I can give. As much as possible, just do well. Okay, go through the video once again and see. Okay, if you, in case if it is needed. Okay, thank you.